Hi, this is Dr. Green. We're working on Web Assigned Homework 7 and problem number 9. So we're looking at a standardized measure that employers would use to gauge how likely new employees with no experience would succeed. One factor might be intelligence, and we can measure that by an IQ score. So to see if that factor is related to job success, an organizational psychologist measures IQ score and job performance in units sold per day for a sample of 5 employees. Here's the data. And then they want us to convert the data to ranks and then compute the Spearman correlation coefficient. So we actually could compute a Pearson correlation coefficient here and see how the data is correlated, but they want us to practice with Spearman, which will use ranked data. So if you don't have the actual data, you can rank it. If you do have the ranks of the data, then you can still see if there's a correlation between the data. So the first thing that we do is we take the IQ scores on the left here. We're going to range them from highest to lowest. So that means switching these two guys here. So 120, 105, 98, 86, and 79. And of course the 98 went with a 42, so we kept the 42 with it, and the 105 went with a 38, and we kept the 38 with that. So we're switching rows, but then reorganize these rows. So now we're going to go ahead and rank the data. So IQ scores, this was the top IQ score. The 120 was rank 1, the 105 was rank 2, 98 rank 3, 86 rank 4, and the 79 rank 5. So these are the rank scores here, 1, 2, 3, 4, 5. And then the job performance scores, 55 was the highest rank, that was 1. And then 42, that was second. And the third highest job rank was 40, fourth was 38, and then the fifth was 29. So 1, 4, 2, 3, 5. And then we're working on doing this by hand here, and then we'll check it with SPSS. So we want to see if there's a correlation between these ranks. So the first thing that you do is you subtract the rank for the x variable or the y variable from the x variable. So subtract left to right. So I've got an x minus y column here. So 1 minus 1 is 0, 2 minus 4 is negative 2, 3 minus 2 is 1, 4 minus 3 is 1, and 5 minus 5 is 0. And then we square each one of these numbers. So you do x minus y squared, and that quantity x minus y is what your book calls d, the difference in the ranks. And so 0 squared here is just 0. And then negative 2 squared, negative 2 times negative 2, positive 4. 1 squared is 1, 1 squared is 1, and 0 squared is 0. And then we sum these up here. So 4, 5, 6. So 6 right here is the total of our differences squared. And then the formula for the Spearman correlation coefficient is 1 minus 6 times the sum of the differences squared. So that sum of d squared, that's this number right here. That's the 6. So this table is just an easier way of finding this. So this is 1 minus, and then the fraction, 6 times 6, and then down below n times, and this should be n squared minus 1, n times n squared minus 1, where n is the number of pairs. So there's 5 pairs here, so n equals 5, and then this will be 5 squared minus 1. And if you key that into the calculator, you get 0.7. Actually 0.700 to 3 decimal places. And now let's go ahead and check it with SPSS. So to do this, we'll enter the data in 2 columns. SPSS will automatically rank the data if they're not already ranks. And then you do analyze, correlate, bivariate, just like we did for earlier problems, except this time you make sure that you check the Spearman box. So let's go ahead and do that. So here is our data, original data. Now I did not even change this to ranks for SPSS because we don't need to do that. So I've got IQ here and then the corresponding job performance here. So we want to do analyze, correlate, bivariate. We'll move our variables over. And then we want to make sure that we check Spearman and not Pearson. And then click OK. So here's our correlation. And let's go ahead and bring that back over to our document. And that's this table right here. And our correlation coefficient is right up here, 0.700. So R is 0.700. So that agrees with what we did up here by hand. And then the significance is the p-value. This is a two-tailed p-value is 0.188. And we need that in part C or part B. So they say using a two-tailed test at 0.05, state the decision to retain or reject the null hypothesis. And this 0.188 is greater than 0.05. So we are going to retain the null. And remember, the null hypothesis is that the variables are not correlated, and the alternative hypothesis is that they are correlated.